Cyrus's new video, Wrecking Ball, but do you actually know what she was trying to portray? Miley was trying to teach us all about the work-energy theorem.
The
equation for the work-energy theorem is commonly known as W net equals delta KE. To represent the work-energy theorem is PEG equals delta KE, or gravitational potential energy equals the change in kinetic energy. To break it down even more, gravitational potential energy equals mgh, or mass times gravity times height. The equation of the work-energy theorem is Ke equals mv squared all over 2, which is mass times velocity squared divided by 2.
In this video, we will take what we learned in class with Mr. Richmond about the work-energy theorem and apply it to real-day applications. Like that, cool. In this video, we will take this work-energy theorem with the givens, her mass, the height, and the force of gravity, and we will put this into the equation to find the velocity at which time whenever she's right here. So we're going to start her from all the way up here, drop her, and we're trying to find out how fast she's going whenever she hits the very bottom point of the pendulum. This equation, we need to find all our givens. We know that the mass of Miley is 0.005 kilograms, and the mass of the wrecking ball is 0.01 kilograms. When combined, it equals a total of 0.015 kilograms.
Mr. Richmond, tell me the acceleration of this falling shoe. Well, it is gravitational acceleration, and it is 9.81.
We have mg and h. We can plug it into the work-energy theorem equation and find the final velocity of Miley.
Show you how to put this into the equation and find the final velocity. So now that we have our givens, we can put it into our equation. That is mgh is equal to mv squared all over 2. Now that we have that, we can set this side equal to v. So multiply by 2 on both sides. This crosses out. So now 2 mgh is equal to mass times velocity squared. And since there's both masses on both sides and they're both equal, we can go ahead and cross out both of these. So then we're left with 2gh is equal to velocity squared. And now we need to get rid of the square, so we can square root all of this. And it gives us this equation. Radical 2gh is equal to final velocity. So we can take this equation and plug in our givens. Radical 2 times negative 9.81 times our delta y, or our height, which is negative 2.39 meters, would equal our velocity. So you may be wondering why we have a negative height in our equation. Height can't be negative, right? But this actually is a delta KE, or change of height, or delta Y, or change of height. When dropped, the Miley is negative 2.39 meters from the surface. So we're saying negative 2.39, meaning the top where we're dropping her is our frame of 0 reference. So it will be a negative direction down. So to finish off the problem, all we have to do is plug into the calculator. Bada boom, bada bing. Velocity equals 6.84 meters per second.